Hello everyone, this is Jacob Beerhorse. I'm going to be detailing how to do Fluent Project 2, flow analysis on a flat plate at different angles of attack. The angle of attack I'm going to be choosing for this project is going to be 90 degrees. You're going to start with your ANSYS workbench, set up your geometry so that way you're in 2D, and then open up your design modeler. Get started from there. We're going to start this sketch in the XY plane. Select your units, make sure you're in centimeters. Okay. Now we're going to begin our sketch. Alrighty. So our height for this one, well, our length is supposed to be 30 centimeters, but since this plate is put at a 90-degree angle, it's going to look like our height. And now our width is supposed to be 0.1 centimeters. Very, very thin. That's okay, we'll work on it. So now you have your dimensions set up. You can then fill out this box. I like to extend that line a lot. You will see why. Okay. Go zoom in. Let's make sure this all looks good. Okay, that's good, right? Trim, trim. Okay. Now you have your shape defined. I want to create this rectangle around it. And this is going to be the profile we actually run our flow through. And then we'll be able to see the results in the future. Now, back to this. Back to concepts. Sources from sketch. Sketch 1. Generate. Make sure this is right. Zoom in here a little bit. Okay. Now that this is updated, we can open up our mesh analysis. Amazing. Well, this is strange. I'm going to exit that. Well, let's just re-update this. And reopen the image. That was very strange. Not sure what's going on there. It's the first time I think that's happened to me. Alright. Now we can begin. So I'm going to start. Let's enter our method. Why? Looks like for some reason these are showing up on my past project. That's okay, nothing to worry. Generate that. See how it's looking. Very nice. Okay. Now we can insert some refinement. Go a factor of 3 for this case. Generate. Now we will also include. Okay, it's looking good. Now let's do our name sections. Links. Okay. Now our top and bottom, control select, and the name is symmetry. Okay. It's back. Wait. Okay. Like I said, these are showing up from the past. I apologize. Okay. Now we just need to go name our smaller parts. Now this is technically going to be our front wall. Like I said, we are rotating 90 degrees, so it will be a little bit confusing at first to understand, but this would be our lower wall. Okay. And that's our upper wall. We'll zoom back out. We'll zoom in this tiny space right here. Edge select and rear wall. Okay. Zoom back out. I like to just look at the mesh one more time. Looks good. Good, 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 good. Good. Inlet center. One. Okay, good to go. Back to your mesh. Make sure you update your mesh. Now we go to our setup. Let's go double precision. Just leave it at one processor for the sake of my computer's help. Now, there's a couple things we're going to change here compared to the first project, but no worry. This is a different analysis, so that does make sense. Okay. So graphics. And something is still loading. So we'll give it a second. But it does look great so far. Okay, well, maybe this is going to let us work. Okay. Let's begin. So you're going to change your viscous layout to Capsilon 2. We're going to do enhanced wall treatment, pressure gradient effects. Okay. Now for your southern, for your materials, project does want you to change this just a little bit. So it wants your density to be 1.2 kilograms per meter cubed, and your viscosity is 1.8 to the negative 5 pascals per sec. Now boundary conditions, the only real thing you have to change here is going to be your inlet. And we'll make this 15 meters per second. Apply. Please. Okay. Really, that's all you have to really do for that case. So make sure the reference is from the inlet. You want to check your length is going to be the length of your specimen. So that would be 30 centimeters for our case. Area then changed to 0.3. Everything else looks good. Here, now we're going to initialize. We'll run this calculation. Number of iterations. I go 100 for this. In the real case, I would run 500. sake of time, we're going to lower it down just a little bit. Still get good results. Looks a little wacky. We'll see though near 100, it's going to level out. Okay. Now, for this project, you are supposed to report the forces. So, for that, we go to Reports, Forces, select all of these, Print, and check your console. So, for this case, we have a couple interesting outputs. Your pressure is, and your forces of pressure is going to be quite large. This is your drag pressure. That is what it should be for this case. Because the angle of attack has changed, you will see your drag forces will increase a lot. Now, when you look at your viscous forces, they are lower here. And that also follows suit because where you have skin drag is in proportionally equal to the pressure drag. So that looks good. Now, that is all we really need for this setup. Now we can open the results and check our contours. Okay, so we do it again. Let's go Z. We're going to create some contours. For the location, you want it to be symmetry 1. You'll see it light up, and you're doing the right thing. Now, for number of contours, I do like to go 50. It's also what Professor Osday chose. So this is looking right. We see our wake region behind. We have massive amounts of pressure at the contact point. This looks right. You would screenshot this, put this in your report. Next, we go to velocity. That's symmetry 1. Awesome. Again, this is where we can see it happening. Where we see high pressure, we see low velocity. And again, coming around, we see these wake regions. This looks good. Now, one other thing you can do is when you insert vectors, analyze it on the symmetry aspect. Do a factor of 3, 5. It's really going to limit the number that you see. We'll get these contours out the way. And here, it really will show you the direction of the flow, as you can see. And now here you see a little bit of turbulence, which is expected. And you will need this in your report for identifying at different angles where there's a transition from laminar to turbulence. For the 90-degree angle, that is not the case, but it's always good to look at this, and it's good endeavor for science. And as this looks right, this is the wake region. Okay. Now, if you were doing the other cases, you would have to go back to your setup and find that. And to find the location of transition, you can always check your XY plot. You would then look at the upper wall, check wall fluxes, X-wall shear stress, curve length, and then you would plot the upper wall. You have your graphics, and here it shows kind of the expected value. You can see the transition to occur. Like I said, that is not required for the 90-degree case, so just for this, you're going to go back to your contours. You're going to screenshot the velocity contour, and you're also going to screenshot the pressure contour here. And then, again, just the forces you tabulated and set up. And then continue this process for the other 3 angles. And I think this concludes the tutorial.